Hey everyone, welcome to another video. Today we're going to be looking at a Xbox One S which has been sent in, and apparently this has been sent in for liquid damage. So it's been a while since I've actually worked on one of these. Not many people send them in anymore because they are losing value a little bit, but they are generally still worth fixing. So this one's been sent in by a customer and they have said that it's liquid damaged, and I'm assuming it doesn't turn on. I haven't actually tested this yet because I never do until I hit record. So yeah, we'll see what's going on with it. But if you are new to the channel and you like this type of content, I would really appreciate it if you hit subscribe and turn on the bell notifications. That way you don't miss any future videos. If you do want to organise a repair, you can check out the website consolefix.co.uk where you can book it in, or you can get in touch if you've got a question about the repair or need a price request. If you do need parts or supplies, you can check out consolefix.shop. That's my online store. I sell a lot of used parts for consoles, as well as some new parts and components as well. And if you do also want to support me, you can head over to Twitch and become a Prime subscriber by linking an Amazon Prime account, which is free for you to do if you've got Amazon Prime, but it massively helps me out. So with that being said, let's get into this repair. Okay, so like I said, I haven't tested this yet, so I don't know what's actually going on with it. It's been sent in for liquid damage, so I'm going to assume that it's not powering on, but we are going to try that first and just see what happens. Let's just have a look. Yep, absolutely no power. Okay, well, that works for me. Well, it doesn't work for me, but you know what I mean. Let's get it apart and we'll see what's going on. It doesn't look like this one's been opened. The warranty stick has been peeled a little bit, but it doesn't look like it's actually been broken, so that's good. And there's no pry marks or anything like that as well, so let's try and keep it that way, shall we? Here we go. Alright, so let's get this apart then. And while I'm doing this, actually, I just want to give a shout out to someone. So there's another YouTuber who is working really hard to gain subscribers and try and build his channel. So Uber Micro Repairs, Lee, is a very good friend of mine. He does console controller repairs, that sort of stuff as well. So if you are looking for some more content, I'm going to leave a link down in the video description to his channel. I really do recommend checking him out. Let's try and get him to 5,000 subscribers, because yesterday I set him a little challenge. If he gets to 5,000 subscribers by the end of January, he's going to do a TikTok dance in his wife's pyjamas. Whether he'll actually do it, I don't know. Probably not, but hey ho. Yeah, just check him out, please, if you don't mind, and give him a follow. Check out some of his content. Very good friend of mine and genuinely nice person, so I really do recommend checking him out. Anyway, back to getting this apart. And this console is incredibly clean. Incredibly clean. It just don't seem to be the kind of thing I'd expect to see from a liquid damage console, to be honest. I mean, I could be wrong. It could still have some liquid damage somewhere, but yeah, it just seems very clean. So what I'm going to do first is just test this power supply and just see if we're getting voltage to the power supply, because if we're getting voltage to the power supply, then it's most likely a board fault. Let's just have a look, shall we? So we'll set that to DC. And yeah, we're getting 12 volts to the power supply. Okay, so very likely a board fault then. The power supply seems to work. I think the power supply can still be faulty, but it's not very likely. And there we go. Okay, so we are pretty much there. Doesn't take long to take these apart. That's what I like about these last gen consoles. They just don't take very long to take apart at all. And yeah, I'm not seeing any signs of liquid damage here. I'm almost certain it said liquid damage on the ticket. That has actually been apart before. That's a bit strange. That's freshly thermal paste, and it's had the thermal paste changed. But that warranty sticker looked mint. Oh well. Well, I'm in continuity mode anyway. So continuity mode is going to tell me whether we've got a continuous path from one probe to the other. And it'll beep when it does, like that. So what I'll do is I'll pop one probe on a ground point, and I'll just use these ports for that. And we'll test the 12 volt input. And And yep, we have a 3.9 ohm short, and that's including the resistance on the leads. So that's pretty much dead short. So when we've got a dead short, what we've likely got is an issue around this area here. And I've covered this so many times, but the thing is, until I actually get into the console, I don't actually know what's wrong with it. And if I hit record, then I'm releasing the video, because that's just the way I do it. So we've likely got an issue here somewhere. So let's pop under the microscope and we'll have a look around there, see if we can see any signs of liquid damage when we get under the scope. So we've got a couple of caps around here, and that's some of these are quite dull, but I don't think that's an issue. It's very unlikely. And we're going to scan around here. So all of this around here can affect the 12 volt rail. Even though it's not all for 12 volt, it can affect the 12 volt rail. So we'll take a look around, see what we can see, see if there's any obvious signs of damage. Again, some grey components, but nothing major. And is that dust or is that corrosion? I think that's just dust. Don't think that's anything to worry about. Yeah, okay. So what I'll do then, I'll go into diode mode. And diode mode is basically going to tell me the voltage drop from the components that I'm testing to ground. And it's going to give me a fast and accurate reading of whatever's going on. So let's just pop the red probe on ground. You have to put the red probe on ground in diode mode, because otherwise you're basically injecting voltage into the circuit. And you don't want to test anything while it's got power going in, because you're going to get a false reading. So what we can do is we can check the gate, which is this left hand pin on the MOSFET. And this one we get a reading of 0.63 volts, which is a perfectly normal reading. So let's move over to this MOSFET here. 0.63 again, okay. I didn't go far enough over, did I? 0.63, Okay, so that's very strange, because these MOSFETs are absolutely fine. All three of them are reading fine. But we do get a short on 12 volt. Let's just double check that. I'm in diode mode, so it's not going to beep. I've turned the beeper off. But yeah, we've definitely got a short on 12 volts, so that's quite interesting. So I wonder if it's a random cap somewhere which has failed. Okay, that cap there shows up as dead short. I don't know if that's a 12 volt cap though. Interesting how the MOSFETs haven't failed. Okay, well, let's make our life a little bit easier then. One thing that we can do is, rather than sitting there testing random components, I mean, there was a cap there short to ground, but rather than testing random components, what we can do is just inject voltage. So essentially, voltage injection means I'm going to force some current through the 12 volt rail, and then the component which is shorted should get hot. So electricity is going to take the path with the least resistance to ground, and what that will do is, because the shorted component is going to have no resistance or very little resistance, it should heat that component up. Now, just because this is a 12 volt rail, that doesn't mean that we want to inject 12 volts. We want to start off as low as possible. So I'm going to go down to 1 volt and see if I can pick up any kind of heat signatures at 1 volt. I'm not going to cap my current. I'm going to keep my current at 5 amps. We get 600 milliamps of current draw. That's probably not going to be enough to see anything with the thermal camera. And yep, that's not enough. So let's go to 1.4 volts. That should be, well, we're getting 1 amp of current draw now, so we do start to get a heat spot around here. So we've got a heat spot here. It's not incredibly hot, but there is, in fact, I can see some corrosion there now. Hindsight is 20/20, eh? Well, alright then, let's look around that area with the microscope then. And, ooh, that's gone with a bang. So we've got a MOSFET here, that's gone with a bit of a boom. And we've also got some components here which are damaged. Actually, that could be liquid damage. There is what appears to be a little bit of corrosion, I think. Yeah, that's taken out quite a few components there, actually. Yeah, that's gone with a bit of bang, that has. So this is going to be the main shorty component, I think. But then we're going to have to change a few other components as well. Like this cap here, for example. Probably change this MOSFET just to be on the safe side. I mean, it does look a little bit charred, and yeah, you got the source here. So the MOSFET source is here. So this is where power comes in. It goes through the gate here, and then it comes out the drain here, and then it goes from there. I believe it goes to here. So it goes in here, through here, across there, and then it goes round to here, through here, across there, and then down to here. So I'm going to change both of these, and I'm going to remove this component and just see what it looks like as well. So there's a chance we might have to replace that as well. Definitely going to have to replace this. I think that's probably a resistor, I'm assuming. So definitely going to have to replace that. Replace that one as well. That one might be good, but I'm going to replace it anyway. And we may have to replace this chip as well. So yeah, quite a bit of damage there, really. Let's just add some flux. I've got my hot air set at 440 degrees at 40% airflow. Let's start off just by preheating. And I'm actually going to go to 480 degrees Celsius, and the reason for that is because this is quite a thick board, and these components are not really sensitive to heat anyway. And yeah, these components definitely got hot. I'm kind of glad I replaced that now, looking at there. So we'll remove those. I'm going to get rid of this cap here as well, just off to the side there. Okay, that should be good. So what I'll do now is I'm going to tin the area with some leaded solder, and then I'm going to show you a little trick for cleaning up corrosion without an ultrasonic cleaner. It doesn't work perfectly, you know, it's not going to be as good as an ultrasonic cleaner, but you know, I'm not going to sit there and ultrasonic this board for the sake of a few components, and plus I need to get rid of the leaded solder anyway, so sorry, the lead free solder, so as I can solder new components on. So what I'll do is just tin this entire area with some leaded solder. This is Kester leaded solder, and by the way, if you can't buy this, you know, if you don't want to import it from the US, you can import this from the US, but I do split these reels up and sell them in 50-gram packs, rather than having to buy a big reel. So if you're a hobbyist or you just need some good quality Kester solder, then check out the website, check out the online store, and you'll be able to buy it on there from me. If you want to import it, you can, you know, if you're a business and you need a large quantity of it anyway. But trust me, 50 grams, that'll last you about a year. And it's genuine Kester solder as well. If you take a look at what I'm doing here, I am running my iron across all of the damaged area, or all of the corroded area, burnt area. And what that's doing is it's breaking up all of the crap that's on the board. And then what I'll do as well is I'll wick away all of the solder now. So all of that solder I've just replaced on the board, I'll wick all of that away, and basically that will, or should, clean the board up properly. It should be beautiful afterwards. So yeah, just blanket wipe the area. It's probably going to be better off long term anyway. And then I can tin all of these solder pads. The easiest way to do this, just make sure you have enough flux on, and then just pop a blob of solder and just run the iron across. That is looking beautiful. Just going to inspect a couple of more areas. We have what looks to be a little bit of corrosion here. Is it corrosion or is it just a little bit of gunk? Let's have a look. It's fine. No need to change that there. That's absolutely fine. Okay, we seem to have a little bit of liquid residue around in a few random spots. There's an area up here which is common for liquid damage, and ooh, that EMMC doesn't look too great. I'll think I may ultrasonic this board, to be honest, but I'll do that off camera because it takes too long, so I'll do it while I'm editing the video. Assuming I'll get the console working, of course. So I'm just giving it a visual inspection in other areas just to make sure we don't have any more damage. I don't think we do. There's a couple of spots around the RAM which don't look the best, but don't think it's really anything to be concerned about. Yeah, we've got a couple of random components that are blue around the board as well. Yeah, so I think I will ultrasonic the board once I'm finished. Just because, number one, I want to make sure that I'll get all of the components which have blue onto the board. You know, stuff that I've took off. And number two, because it seems like we did have a little bit of liquid damage in places, but the main issue here seems to be the 12 volt rail. But I will ultrasonic this board just for the, you know, just to make sure that it's 100% when it goes back to the customer and that they're not going to have any more issues going forward. But I think that's absolutely fine. Okay, so that's how it would be assembled inside the housing, so that's absolutely fine in terms of testing. Make sure there's nothing underneath. We've got a couple of components, I'll move them. And then ready for testing. Okay, cool. And I guess the board's still a little bit warm because the fan ramped up. But we definitely have power back in the board now. Oh, no. Oh, hang on. Okay. That was a little bit odd. But it's working now. Sometimes we do get that where it'll turn on, turn straight back off, and then it'll work again afterwards. It's really strange. I'm not sure why. Maybe it's just a MOSFET which is stuck or something. I don't know. Okay, eject is not work. Oh, I thought eject wasn't working. It is. Rayman Legends, nice, beautiful game. I like Rayman. Rayman's a good game. Right, let's connect up a HDMI. Make sure that we get a display. Boom. That's what I'm talking about. Let's give it a full test. I'm going to sync a controller. Whoops, I pressed the eject button by accident. Damn it. Well, at least I know that the disk drive works. Okay, so I've synced the controller. And he's just fired Rayman Legends straight up. So now, yep, now I know the disk drive works fine. And connecting. Yep, that's all working fine. And yep, we get a good connection on the internet. So it's going to show you in 1080p. It's not going to work in 1440 or anything because it's connected to the capture card. It never does for some reason. I don't know why. It's a 4K capture card. It just don't ever seem to work. But that being said, that's working. And there we go. That's job done. So turned out that the short was on the 12 volt rail, but not in the typical place that we normally get shorts. That area went with a bang. It wasn't happy at all. But replacing those components, I've replaced some just for precautionary measures. I'll get my words out. But yeah, I've replaced a few just for precautionary measures, and yeah, the console seems to be working absolutely fine. The Wi-Fi works, the front panel works, disk drive works, HDMI output works, the fan seems to be spinning, and the console seems to be working. So hopefully the customer is going to be happy, and hopefully you enjoyed this video. If you did, don't forget to leave a like on the video and tell me what you think down in the comments down below. If you do want to organise a repair, you can get in touch using the website in the video description, consolefix.co.uk. You can book in the repair, or you can get in touch if you've got any questions or need a price request as well. If you do want to buy parts and supplies, consolefix.shop, like I said earlier on. You can buy parts and supplies from the consoles that I've stripped down in the past. And of course, if you do want to support me, check out the ways that you can do so in the video description. But other than that, thank you very much for watching. I really do appreciate it. And until next time, I'll see you later. Bye for now. Hey again everyone, it's Future Coder here. I've tied Past Coder up and I've stuck him under the desk. So don't tell anyone that he's there. We're going to keep it our little secret. But I just want to show you this board now that it's come out of the ultrasonic cleaner. It had about 10 minutes at 60 degrees Celsius. And it looks pretty damn sweet, if I do say so myself. So yeah, I'll show you this under the microscope really quickly, and then we'll end the video. And then I'll let the coder back out. Alright, so this is the area that had all of the rework, and as you can see, it is absolutely mint. Nothing at all wrong with that. Don't worry about that little bridge. That's the drain on the MOSFET, and all three of those pads are linked together anyway, so don't worry about that. It's perfectly normal. You lose a little bit of the conformal coating and then those pads end up bridging, but it's absolutely fine. But yeah, it looks absolutely mint, and if you even look at around the RAM and stuff like that, you'll see that there's absolutely no signs of liquid damage whatsoever. So it all looks pretty darn sweet. We do have that burnt cap there, but it's nothing to worry about. It's just a little bit of charring. But other than that, yeah, it looks absolutely fantastic. So this was in the ultrasonic cleaner, like I said, for around about 10 to 15 minutes at 60 degrees Celsius. And yeah, the results speak for themselves. Absolutely beautiful. It's still a little bit wet. I still need to give it a little bit of drying time. But other than that, yeah, job well done. I'm happy. Alright, now I'll let current coder out so as he can do another video. See you all later.